So in this session, we'll talk about performance and polyglot superpowers for Java with GraalVM. So basically all the things that you can do for Java using GraalVM. Let's talk about that. The first thing, I want to give you a quick overview of what GraalVM is and what it does for those of you who maybe are less familiar with it. So GraalVM is a high-performance universal virtual machine. So it can execute all those languages that you can see on top here. Also, it can work in a number of environments and embeddings, the ones that you can see here below. And the idea is, and basically the mission that our team has, is that you can execute all of those languages with high performance. So basically we want to make every language, every application run faster with GraalVM. Now let's take a closer look at what GraalVM can do for us as Java developers, right? Since we are at the Java conference. So one thing GraalVM can offer for you is more performance in JIT mode. This is coming from the fact that GraalVM comes with a new highly optimizing top-tier compiler, thanks to which many applications will see additional performance just kind of out of the box without any performance optimizations needed from developers. So migration is very easy in that scenario, and we will take a look at it in a second. Now, another very interesting and kind of highly popular component of GraalVM is native image. You may have heard about it previously. So that is the component that allows you to take a Java application, compile it ahead of time into a platform-specific native binary that can run without a JVM, so be fully independent on its own. And that's why it can start really fast and can use way fewer resources. And the last but not least, GraalVM is also a polyglot virtual machine. So you've seen how many languages it can execute, right? It can be Java, JVM languages, can be JavaScript, Ruby, Python, LLVM languages, you name it. And not only it can execute each of those languages separately, but also it can execute polyglot applications where you combine and kind of mix and match those languages as you wish. So GraalVM would give you this interoperability out of the box, but also will optimize the whole application. So you can still run with high performance no matter how many or which languages you are using. Let's talk about each of those capabilities in more detail. Before we do that, though, I want to kind of give you this quick overview of the architecture. So what GraalVM looks like from the inside. So as the base, we usually have Java hotspot VM, right? And we replace the top-tier compiler, so the C2 compiler with GraalVM compiler. And in this layer, so the base layer, you can already execute Java languages such as Java, Kotlin, and so on. To execute all those additional languages that we implemented on top of GraalVM, we have something called Language Implementation Framework, namely Truffle, and that is the way we implemented all those languages that you see here, but also that's the way that you can fairly easily implement a language on your own if you want to implement your own language or come up with a new implementation for an existing language. So this is kind of high-level overview of the architecture and what components are inside. What's interesting, GraalVM is also a huge open source project. Our development is happening on GitHub, and somebody even told me, I don't know how accurate that is, that GraalVM is one of the biggest open source Java projects. So indeed, it's very big. It, in fact, consists of multiple repositories. And if you're a Java developer, it's quite interesting. I encourage you to check it out from the inside, because most of it is written in Java. So it should be fairly accessible for you to understand what's going on there and what each part and each component does. So some of the key parts of GraalVM as a whole are so the core repository, which includes the compiler, the runtime for native image, which is called SouthStart.VM, Truffle, so the language implementation framework. This is basically the core distribution. And then we have language implementations, the one we see here on the left. So languages like JavaScript, Ruby, Python, and tools like, for example, GraalVM, which are also separate repos. So let's talk a bit about what we can do for Java applications with GraalVM. So first thing is you can use GraalVM as a JDK. And I want to kind of emphasize this because the native image component of GraalVM is so exciting that many people associate GraalVM with native image. And while indeed it is a part of GraalVM, but also it's not the only part, right? So you can also use GraalVM as a normal JDK, just you are using, for example, OpenJDK, for example. So the way you would use GraalVM in this scenario is just you would replace your JDK distribution with GraalVM. You can use the same tools, libraries, whatever you want as you would use on any other JDK distribution. And the part that changes in this scenario is that you get a brand new, highly optimizing top-tier compiler. The rest stays the same, so this migration process could be fairly easy for you. And it is available for Java versions 11 and 17. So if you are using one of those, it should be super easy for you to move to GraalVM and see if you can get additional performance benefits for your applications. So I said that GraalVM can be used as a JDK, right? And I wanted to, like, if there is one thing you would take from this presentation, I would like it to be this slide, right? Where you can use GraalVM to execute Java in multiple modes, right? So you can use it in JIT mode, where you run your application with a Java command like you would run any other application, right? And then in native image mode, where you get those startup and memory improvement benefits, right? So with GraalVM, you can use either of those, and you kind of get a choice with GraalVM depending on what kind of performance profile for your applications you want to achieve. And to make this chart complete, there is one more way to execute Java on GraalVM. I wouldn't stop here to not confuse you about this. Also, this is not a topic of today's session, but just to give you an example, I'll give you a full picture. So remember, we talked about Truffle, which is a language implementation framework on top of GraalVM. So we also implemented Java in the same way on top of GraalVM, on top of Truffle, so it can have even better interoperability with those Truffle languages like JavaScript and Python and Ruby, for example. So in fact, there are 3 ways to execute Java on GraalVM, which I think is quite cool. But for the purposes of this session, we will just focus on those 2. So let's talk a bit more about this native image mode because it's so exciting and a lot of people like it and a lot of people have tried it, and I always get questions about this. Let's talk about this one. So GraalVM native image is a technology that allows you to take your Java application, compile it ahead of time, use a platform-specific native binary out of your application. And the reason you would do so is because this binary no longer requires a JVM to run, and it has been pre-compiled, it has been optimized ahead of time, so before the application run. And this way it can start really fast, can use very little resources, and can also come with a much smaller packaging size, which could be important for resource-constrained environments. It's also great for cloud deployments. So I think we had a talk from Mark from AWS at this conference today, right? So probably he mentioned how GraalVM native image is a great runtime for AWS Lambda. And it really is, right? Because for serverless workloads, you want to have really fast startup, use as little resources as possible. And that's one of the ways where native image really shines and really is beneficial for Java applications. Let's take a closer look at how exactly native image compiles Java applications ahead of time, because as you probably know, Java in its nature is quite dynamic, right? So how do we approach compiling Java ahead of time? So there are quite a few things going on when you are running native image command to build your application. So one thing we are doing is we are starting static analysis of your application. So starting from the main entry point of your application, we are trying to find all the code that is reachable. So basically all the code that is functional for your application, that is needed for your application to perform, to make sure we only compile and package that code that is actually needed in the final produced native executable. So what we want to accomplish here is to eliminate all the code that is not necessary for your application to run, making sure that this final executable is as small and lightweight as possible. Another thing we are also doing during the image build time is we are performing heap snapshotting. So we are running initializations and we are snapshotting your heap as we are building the image so that your application, when you actually run it, can start with the pre-populated heap. And this way it can also start faster, right? Because the heap is basically ready to go from the very first milliseconds of your application run. So this is basically what happens. We analyze your application, we analyze all dependencies that it has, we compile it, only the parts that are necessary for your application to run, and then we produce a native executable that contains all that code and that also comes with the image heap that was pre-populated at the image build time. And the idea here is to move all the heavy lifting, right? So all the resource intensive operations to the image build time. So at the runtime, you do not need to repeat those operations and your application can start really fast every single time. So to compare how much faster the native image mode is comparing to JIT and where this difference in time and resource usage is coming from, if you're looking at how your application is executed in JIT mode and in native image mode, you can see even like visually without reading how much longer the list of operations is in the JIT mode, right? So for your application to run in the JIT mode, you need to do the following. So the GVM executable itself needs to be loaded. You need to start loading classes, interpreting, compiling, collecting profile information, then compiling with the top tier compiler. And then at some point when your application warms up, when all those operations have been performed and compilation has been done, you can run at some point with the most optimized compiled code. Now with native image mode, since we've done all of this at the image build time, you don't need to do it. You do not need to repeat it at the image runtime. You can start with the executable that already has been compiled and optimized ahead of time. And the same applies to memory usage, right? So we will see in a bit how much more efficient native image is in terms of memory usage comparing to running in JIT mode. But basically, again, you don't need to keep around memory for the JVM executable, for the compiler, data structures, and so on. You only need memory for the application executable and the application data. That's all you need. And that is basically that idea that I mentioned of moving all this heavy lift into image build time. So you can do it once and then your application fast every single time when you actually need to run it. Okay, so what if this looks interesting to you and you want to try and build your first application? So the easiest way, like no effort way, would be to clone our demos repo, and we have a bunch of applications for the native image capabilities, for polyglot applications, basically a lot of already available apps that you can build and try on your own and see how that is working out for you. So that's an easy way. If you would like to try something more complicated, but also custom and create your own application, and also in particular, if you're interested in this native image component that I'm talking about, right? What I recommend is trying building your first app with one of those frameworks that work great with GraalVM native image, because frameworks will give you a lot of features and configurations and support out of the box. So that is the easiest probably way to build your first application. So one of such frameworks is Micronaut. It's a great framework for building serverless and microservices application, but also basically any kinds of Java applications. And it works really great with GraalVM and native image in particular from day one. So it's really well integrated, and the support for native image is really great there. So the way to build your first application would be either to go to their Micronaut launch page and configure the project as you would like it to be, or use their CLI utility to basically do the same thing, whatever works better for you. An interesting fact here, so their CLI utility, this one, MN, we can see on the screen here, I believe it's also a Java application compiled using GraalVM native image. So if you ever use this Micronaut CLI utility, you already kind of used GraalVM native image in practice. And to illustrate that thought about fast startup and low resources usage, so here we are looking at the Micronaut application. That's basically a web server that is running in one case on GraalVM JIT, right? So in JIT mode, and in second case as GraalVM native image, but basically the same application doing the same thing. And you can see how in first case it is starting in 3.3 seconds. Right, so 3,000 milliseconds, but then compiled as native image, it starts way faster, so in 0.1 second. And that's basically the same application doing the same job, only it was optimized in a way that it ensures the best startup and the best resources usage. Now, if you want to do some more extensive measurements and also measure how much time it takes for this web server to actually perform some valuable work, so not only to start, but serve first request, we can see that the results are similar, right? So it starts faster in the native image mode and uses way less resources. So in our scenario, way less CPU time because you've compiled and optimized this application ahead of time. And this native image is a really great platform for this kind of applications, right? So web server that maybe needs to serve requests once in a while, but while it is idle, you want it not to use resources, right? Because it's not doing any valuable work at the time. So here we are looking basically at the same application, and we see that in JIT mode, so those red vertical lines, that is CPU usage, and the green horizontal one is memory usage. So we can see that in the JIT mode, our application is quite busy up until like 3.5 seconds, right? And also it's using significantly more memory. While in native image, both CPU usage and memory usage are way more reasonable. And again, on the right, we see that when actual requests arrive and need to be served, so maybe like once every second, even when those requests arrive, it is still not using as many resources because it's way more efficient. And another angle to look at the efficient resources use of native image is this example of horizontal scaling of microservices. So here we are looking at the application that we are running again on the JVM and in native image mode. And if we want to scale, so add more instances of the same application, we see that in terms of memory usage, native image, which is in red, is way more efficient, right? Because native image applications can share in between them things like image heap and machine code, despite being way more efficient and better for things like here we see horizontal scaling of microservices. And I talked about Micronaut, right? So I can see this question coming. So what about Spring Boot? Can I do Spring Boot applications as native images? And the answer is yes. So there is Spring Native project that is still work in progress, but many applications already work out of the box. You can give it a try by getting it from GitHub, or it also is now available at start.spring.io. And here are some measurements that they share of running on native image. So you can see that here on right, like far left, that is running on JVM, and then running on the native image mode, and how much smaller container image size is, but also how much faster startup time is. And this is still work in progress. I believe these are numbers from Spring 1 last year. So waiting for new results coming in the end of the year, really looking forward to it. And another cool example that I really like, so there is this projectGhipster that allows you to easily bootstrap fully blown big Java projects, such as, for example, here web applications, and it gives you on the back end things like Spring Boot, Micronaut, Quarkus, basically a framework of your choice. And then on front end, you can have things like Angular, React, Vue.js, whatever. And it's also working with native image. So here I'm running myGhipster application, which is a Spring Boot applications with Angular, I believe it was on front end. And again, it's a big application, so application, but we can see that it's starting in 1 second, which is quite cool. So give it a try. I think you will like it as well. Okay, so that's like, how do I start working with native image, but how do I make the most out of it? So are there any things I can do to make native image even better? And the answer is yes, there are. So one thing you can do is optimize performance of native image. So the thing is that native image is performing quite well in terms of startup. So as we saw, it starts fast, is using resources very reasonably, but then in terms of peak performance, it might need a little help from you to optimize for the most, right? And one thing you can do is use so-called profile guided optimizations. So the reason, for example, running on JIT is so great, right, is because when you're running on a JIT, so executing your code dynamically, the JVM is collecting profiles, and based on these profiles, it adapts and executes your application accordingly. So one thing you can do is you can collect this profile information, feed it to native image at the image build time, and then native image can build your Java application aware of those profiles. So kind of getting an insight into how your application will behave at the runtime. And this way it can produce a native executable that is specifically tailored for the best peak performance based on your application behavior. So that is one thing you can do to optimize for the best peak performance. And then in terms of memory management, and again, as another way to optimize performance of native image applications, there are several GC options available. So by default, what you get is serial GC, but you can also do G1 GC if you want to optimize for the best possible peak performance. And you can also get epsilon GC in case you don't want to do any GCs at all. So if you want to maximize peak performance to the most, the combo you would use probably would be using PGO and using G1 GC, and that will give you the results in terms of peak performance comparable to running in JIT mode, so comparing to running like on something like OpenJDK in terms of peak performance. Okay, and a few more things that you can do with native image is one, you can monitor performance using JFR. That is still work in progress and something that we collaborate on with Red Hat, but there are quite a few features already available. So if monitoring performance with JFR is something interesting for you, you can already do it in native image mode as well. And if you want to read a bit more about native image, because I want to switch to talking about polyglot capabilities in a bit, we also have this article at InfoQ where you can talk about, you can read about more about it, how it's working from the inside, what you need to know, what you need to be prepared for, and things like that. Okay, and one more thing, we also have those official Gradient and Maven plugins for native image. We call them native build tools. So if you're building your project with native image in mind, it's probably best that you use those plugins to configure your build. And also it simplifies JUnit testing in native image mode as well. Okay, and I want to talk a bit more about what's new in GraalVM. So quite a few changes are around developer experience improvements. The first one is introducing quick build mode. So when you're building a native image, right, it can take significant time depending on how big your application is, because it has to perform a lot of work. So it needs to figure out your whole application, what it's doing, what its dependencies are, what code is actually being used, and how to optimize that and put it into one executable. So if your application is bigger, this build process can be longer. So one thing we recommend is when you're developing with like native image platform in mind, one thing you can do is you can develop your applications on a JDK, so in JIT mode, but then as a more or less final step in your development cycle, compile to native. So once in a while, but probably not on every minor change. Another thing you can do is you can use this quick build mode. So it makes build process way faster, but at the cost of peak performance. So this is something we recommend for development purposes, where you want to produce your build quickly, get quick results correctly, but you don't care much about performance because this is development purposes. So in development, you would develop using this quick build mode, but then for final deployment, you would switch to normal compilation mode to make sure you have the best possible peak performance. Another change is we are also reducing build times outside of this quick build mode. So even when you are using normal default build mode, we are still making sure to cut those build times. So over the last year, we cut those in like around 30%, I would say. So one more change I wanted to mention related to developer experience improvements. We now have a smaller JDK distribution. So components like JavaScript and LVM, they are not no longer part of the base distribution, but they can be installed separately. So this way you get more modular, smaller base distribution. And if you need components that were removed from the default distribution, you can just install them with one quick command. But as an outcome, you get the JDK of the size of around 200 megabytes, which makes it way smaller and more lightweight. And one more cool update that I wanted to mention. So GraalVM native image, in some cases, may require additional configuration provided by you. That is, if you want to include or use some of more dynamic Java features, such as, for example, reflection. So when native image builds your application, it does so under closed world assumption, right? So we are doing this ahead of time. And if you need to use those dynamic features, there is basically no way of native image to know that you will be accessing those at runtime. So the way to approach this would be to give configuration to native image at the build time, telling what exactly needs to be configured to be working at the image runtime. And there are multiple ways to produce such configuration. So you can do it manually. You can leverage the tracing agent that we'll have that will observe your application behavior in a JIT mode and help you produce this configuration automatically. Or the most recent change, we also built this GraalVM metadata repository where library of framework supporters and other native image users can all contribute metadata repo to this repo. So other users of those libraries and frameworks can reuse configuration rather than producing it on their own. So to enable using this metadata repo is fairly easy. So here, for example, in a POM XML file, you are just adding one more step to the you're saying that you want to enable using this repository, and this will allow you to pull this metadata from this central repo. So we just introduced this maybe a month ago. We are still building out this repo, but your contributions are welcome as well. And we plan this to be a centralized space for metadata info so that people contribute it, share it, and reuse it. Okay, and to talk about polyglot. So we mentioned all languages, right? That you can execute each of them on GraalVM or even combine and mix and match them. And I want to say a few more words about that. So the main benefit is that you can not only use each of them, right, but also you can use them together. And GraalVM as a platform will give you a number of things for such kind of polyglot programming. So it will give you optimizations for the whole application. It will give you tooling, and it will also ensure that you have this interoperability out the box along with security features. So the way to build such polyglot applications would be, for example, like here, the following is that we have our base host application in Java. And if you want to extend it with some Python code, we would just create a context for it, specify that this is exactly Python we want to use there, and then provide this actual Python code. So this is a basic structure of such polyglot application. And I mentioned a bunch of languages that are coming from our team, right, that are officially present and supported on GraalVM. But also what's interesting, there is a number of languages that are developed by community, and if you want to, you can check them out on your own. So one of those languages is, for example, Lua. I'm sure you've heard about it. Also, we have implementations such, for example, Reactive Ruby, or even a community implementation of BrainFuck on GraalVM, which is quite cool. And talking about tooling, there's also a bunch of tools that you can use for polyglot programming on GraalVM, because in general, polyglot programming is not so easy, right? So you need proper tooling for it. And you can use, for example, Chrome Inspector, or you have CPU Sampler and the Flame graph that we can see below. This is actually produced by our CPU Sampler. So you can even get better insights into your application is performing and how much CPU is spent in each of those application parts. And a few more cool examples of what you can do in terms of polyglot programming. So where we see GraalVM being used quite often is, for example, for server-side rendering of JavaScript. Because if you already have GraalVM on your backend and you have, let's say, Java or Scala or whatever there, but you also need to perform server-side rendering, it makes a lot of sense to do it on GraalVM, because GraalVM can execute JavaScript with its own runtime. So basically, you can have just one runtime for your whole application. Or you can even do more crazy things. Like, for example, here we are combining JavaScript, Java, and R to build such application. Or another example that I like, this is actually built by one of our colleagues back when COVID was just starting. So it's a basically data science application that is using Java, JavaScript, Python, and R to analyze and build COVID trends in a specific region. And it's using separate libraries from all those languages to produce such charts. And you can also use, so I'm talking a lot about Java here, right? So you can also extend Java with some Python libraries. As it's probably know, a lot of machine learning libraries are specifically in Python, right? It's kind of famous for machine learning. So here our team at Oracle NetSuite extended their Java application with Python libraries to build a recommendation engine for their e-commerce solution. An example of using native image in production. So this is from Alibaba. They moved to native image to run their applications in the cloud. And you can see how much faster, so around 20x, the applications are after migrating to native image. Okay, so how do you get started with GraalVM? This is basically what our release roadmap looks like. We have 4 releases each year. So basically every 3 months we have a feature release, and then the last release of the year. So something like 22.3, 21.3 will be supported for longer. So we'll receive updates for longer. And if you want to get started, you can download GraalVM from graalvm.org. Or probably the easiest way to use GraalVM is if you're using SDKman, you can just install it with SDKman and see and try running your applications on GraalVM this way. Okay, and a few more links. So here's where you can download GraalVM. If you want to follow updates, we are very active on Twitter, and we also have a Slack workspace where you can ask us questions. That's it from my side, and I think I'm more or less on time. I guess we can do questions now.
Yes, we have a bunch of questions. Thanks, Alina. You sound so great and convincing. I did enjoy listening about superpowers for sure. Let's see what we have. Okay, just a moment.
Sure.
Okay. So the first question: what's Oracle plan for GraalVM? Are we going to merge OpenJDK or will we have parallel platform?
Yep. Nice question. Thank you. So GraalVM, as I mentioned, is an open source project, right? And so is OpenJDK. And those are two kind of related, but also separate projects. So I would say we benefit from each other in a way, but still those are two separate projects with separate communities. I don't think they will be merged.
I see. And we have questions about the price to pay for superpowers. Does GraalVM native image support reflection?
That's a great question, and I like the way it is phrased. So native image does work with reflection, but it does require configuration, right? So reflection in its nature is very dynamic. So it's kind of hard for native image to automatically figure it out because like native image cannot predict how exactly you are planning to use reflection at runtime. So you can configure a reflection. So you can tell native image which parts of application you want to access reflectively. And you can do so configuration. So there are multiple ways to do it. You can do it manually. You can use our tracing agent, or you can use hopefully our new metadata repository. And sometimes also frameworks would also help you figure out reflections out of the box. So it does support reflection, but with a bit help from you.
There is also a question about slides. Awesome, thank you. Where are slides available, please? So I believe you will share them after the conference, right?
I can. I guess I can just upload them somewhere. I don't know if the conference is planning to send out those slides, but also, like, yeah, I think I can publish them somewhere, or you can ping me on Twitter, and I'm happy to share the slides with you.
Okay. And also difficult maybe question, does GraalVM supports any profilers? I think it's a GraalVM native image maybe. And what about Java flight recorder and Java mission control?
So Java Flight Recorder is supported to certain extent. It is still being built, this support. So I believe what is supported at the moment is some, how do you call them, like VM events or system events and also custom events, but we are still adding more. As I mentioned, we are also working with Red Hat on this, so big thanks for for contributing to this. So JFR is work in progress. In general, other tools I would need to check out maybe and get back to you. But yeah, JFR for sure, it's work in progress. Some things already work. You can give it a try. Also, I believe we have this demo published in our GraalVM demos, so you can also try it out there.
Any other price to pay with GraalVM native image?
People always ask these questions. People are always a bit suspicious when you talk about benefits of something. They want to know what are the downsides of it. I wouldn't say there are downsides to using it. So, or sometimes people ask this, like, when I don't need to use GraalVM, so what are the bad cases to use GraalVM? In general, I would say always use GraalVM, but just choose the right element of GraalVM for your goals. So I did not talk this in this session, but in general, if you want to have absolute best possible peak performance, then give GraalVM JIT a try. So run on GraalVM and JDK, and then running in this dynamic execution mode would give you the best possible peak performance. So if you would rather have great peak performance, but also the absolute best startup performance, so what we call instant performance, then do use native image because it will give you the best actual startup and memory usage. So depending on what is more important to you, right? So peak performance or this so-called instant performance, you can use GraalVM in JIT or you can use native image. But other than that, there are no downsides to it. I do want to add probably that in native image times, you do need a bit more configuration or a bit more work from your side to make application work. So some applications would compile to native easily from the first attempt, right? In some cases, especially if you're using a lot of those dynamic Java features, that might require some work from your side, but we are making a lot of progress in that regard. So hopefully it will get easier soon.
Thank you, Alina. I think that's all about our questions, and I'd like to thank you for this talk and the whole support to this event, because all the profit from sales of the tickets will go to Ukrainian charity funds, Voices of Children, Razom, Nova Ukraine, and Sirius, and that's all helps us to bring victory closer.
Thank you a lot, Artem, and thank you, the organizers, for having me. Good luck with next talks.